I will teach you two ways to solve this difficult problem. First, let's use a kill in seconds method. I'm telling you, you can just stare at it and figure it out. This is 10, this is 50, and this is 200. Some people might ask why. Let's look at what 1/8 equals. If you write it as a decimal, it equals 0.125, right? So within this 0.125, I'm going to break it down. First, I can extract a 0.1, and you can see that 0.1 corresponds to solving for 1/10, which is perfectly fine. And then this 2 actually corresponds to 0.02. What does 0.02 equal? Written as a fraction, it's 2 100ths, and 2 100ths is equal to 1/50th, so this number equals 50. Third, this 5 is actually 0.005. 0.005 is 5 over 1,000, and 5 over 1,000 is equal to 1 over 200. So you see, you can solve it instantly just by looking at it. Are there any other methods? Well, today Teacher Jin is going to teach you a universal construction method. How should we write it? I won't worry about the answer being 1/8 for now. I'll use a simple one to give you an example. We know that 1 is just equal to 1. That's indisputable. But how do I establish a relationship with the fractions in the original problem? I'll write it in a way that relates to the fraction. I'll say I'm subtracting 1/2 at the end. But if I do that, the answers on both sides of the equal sign definitely won't be equal anymore. To make them equal, I'll just add 1/2 back, right? Some might ask, what are you doing? Subtracting one moment and adding the next. Isn't this just a waste of time? Let's take a look. You see, there are fractions in the original problem, and the numerator of the fractions is 1, so I am constructing something on top of this problem. So when can I stop? Please remember, however many fractions there are in the problem, you should construct it up to that fraction. For example, if there are only 2, then you write it up to 1/2. There are 3 in the problem now, so you construct it up to 1/3, subtract 1/3, and then add back 1/3. If there were another 1/4, then you would write it up to 1/4. It's very simple to construct it. So what can you do after you've constructed it? We need to perform a simple consolidation. The problem requires 3 fractions, so we will also combine this string into 3 fractions. This is the first one. Write it out and subtract, and you get 1/2. And this one, what does it come out to be? It's 1/6, and there's also a 1/3 here. I'll tuck it in the middle. It looks more comfortable that way. See, doesn't this result in 3 fractions with a numerator of 1? However, there is still a small issue here. Our final answer is not 1, but equals 1/8. So how can we make it equal 1/8? This part is simple now. If I multiply the left side by 1/8, then obviously I must also multiply the right side by 1/8. Then using the distributive property, we expand it. What does it equal? 1/2 times 1/8 is 1/16, then next is 1/24, and then 1/48. So for the first way to fill this in, what we call the eyeballing method, you see I can just write it like this. For the second method, we can also let A equal 16, this one equal 24, and C equal 48. Have you mastered both of these methods?